These are the graphing quadratic functions or graphing quadratic equations foldable notes. You'll fold your paper in half vertically, and then when you've done that, if you were to turn it sideways, these are the holes in your paper. You would then fold it in half horizontally and in half horizontally again. And so what will happen is you'll have four distinct folds. Then you're going to use your scissors and you're going to cut on the folds here. So you'll have flaps right here, 4 of them to be exact. So on the front of flap 1, you have standard form when b is 0 from chapter 5.1. The equation for that is y equals ax squared plus c because b is 0. Your second flap will be standard form, also from chapter 5.1, y equals ax squared plus bx plus c. And then the newer ones that we're getting into are intercept form, y equals a times, in parentheses, x minus p times x minus q. This is going to have x-intercepts, and the intercepts will be p, comma 0, and q, comma 0, because x-intercepts always have 0 as their y-coordinate because they sit right on the x-axis. The final form's flap 4 is vertex form, and that equation is y equals a times, and then in parentheses, x minus h squared plus k. And the things that you need to know about the vertex form is that the vertex is going to be the value h as your x-coordinate and the value k as your y-coordinate. And your axis of symmetry is going to be x equals h, because the axis of symmetry always passes through the vertex, so the x-coordinate of the vertex matches your axis of symmetry. Once you've set this up, go ahead and continue the recording, because we'll be filling in the flaps that are underneath. Okay, we are now, I'm going to enlarge these essentially. We are underneath flap 1, the one that says standard form when b equals 0. It's right here. And we're going to write, and you're going to need to write kind of small. You've already glued in your graphs, so you should be good. So underneath that flap, you've got y equals 1/4 x squared minus 3. You need to write your a, b, and c. A is 1/4, b is 0, c equals -3. The first thing we find is the axis of symmetry, and we kind of do that simultaneously with the vertex. We know that when b is 0, the vertex will be that c amount, 0, -3. And so when we plot it, 0, -3 down here, we can see it's falling right on the y-axis. And so it crosses, your axis of symmetry will cross the x-axis at 0. So your vertical line, your axis of symmetry is x equals 0. Make sure you label it as such. Please label your vertex 0, -3. We know it's going to open up because the a is 1/4, it's positive. And we also know that it's going to be wider than the parent function. It's going to be wider than the parent function. Anytime you have an amount for a less than 1, so it's going to be a proper fraction, it'll be wider than the parent function. Now we come back to what we're doing here. The second thing is to find and plot 2 points. Now usually we choose 1 and 2 as x values, but if you put 1 in for the x, you'd end up with 1 squared or 1, which would leave you with 1/4 and a fraction. And so that doesn't work very well. Let's try 2. So if I put in 2, it'd be 2 squared. That one's going to work because 2 squared is 4, and you can take 1/4 of 4 and get 1. So here's our work. We chose 2. So 2, y equals 1/4 times 2 squared minus 3. So y equals 1/4 times 2 squared is 4. So 1/4 of 4, that's like dividing by 4. Taking 1/4 is like dividing by 4 minus 3. So 1/4 of 4 is 1, so y equals 1 minus 3, which is -2. So your ordered pair is 2, -2, which you can see plotted down here on the graph. Now I'm going to go to step 4, and we're going to reflect that. So it was 1, 2 from the axis of symmetry on the right. Go 2 to the axis from the axis of symmetry on the left. It's going to be -2, -2. Okay, we need 5 points, so we're going to get another point. 3 won't work, because if I plug in 3 to the equation, it'd be 3 squared, which is 9. 9 does not divide evenly by 4. So we go next to 4. 4 squared would be 16. I can divide 16 evenly, so that's where we are right here. It'll work. We're going to choose 4. Y equals 1/4 times 4 squared minus 3. 4 squared is 16, so we're taking y equals 1/4 of 16, meaning 16 divided by 4, minus 3. 16 divided by 4 is 4, so y equals 4 minus 3, which is 1. So our ordered pair is 4, 1. You can see that right here, and it is plotted right here, 4, 1. We are then going to reflect that point, so it's 1, 2, 3, 4 from the axis of symmetry on the right. So go 1, 2, 3, 4 from the axis of symmetry on the left, so it's negative 4, 1. Plot it, label it. When you connect it, you can see you have a rather wide parabola. All 5 of your ordered pairs are labeled. Okay, flap 2 is standard form, and it's y equals negative x squared minus 8x minus 13. So we're going to do A, B, and C. A is negative 1, B is negative 8, and C is negative 13. Because A is negative 1, you know that the parabola is going to open down. Now, with that said, the next step is going to be to find the axis of symmetry. So the axis of symmetry is given by the formula x equals negative 1 times b over 2a. They write it as negative b over 2a, but I like this little stretching out of it. So then we have x equals negative 1 times b is negative 8. This is where it's really important that it's stretched out. And then 2 times a, which is negative 1. And then we're going to have negative 1 times, we have negative 8 over negative 2, which is going to be positive 4. So negative 8, 2 times negative 1 is negative 2. Negative 8 divided by negative 2 is positive 4. So x equals negative 4. Go ahead and circle that. We're going to draw that in right now. So let me move this graph up. Your axis of symmetry is x equals negative 4. So you're going to put a vertical line. I always use a broken line. It's imaginary. X equals negative 4 is the equation. Let me write that a little smaller. X equals negative 4. And we know that the vertex is going to share the same x coordinates. So when we go down to the vertex, step number 2, we know already what the x coordinate is going to be, and that's going to be negative 4. So we're looking for our y coordinate. We're simply going to use the equation y equals negative x squared minus 8x minus 13 to help us. I'm probably going to use the subtraction rule to be a little more accurate. So y equals negative 1 times negative 4 squared plus a negative 8. Again, I'm using the subtraction rule. Subtraction changes to addition. 8 changes to negative 8. X is negative 4. And then I'm going to change this to plus a negative 13. Again, I use the additive inverse or add the opposite to help me with that. So we have y equals negative 4 squared is negative 4 times negative 4, which is 16, times negative 1 is negative 16, plus, and then we have negative 8 times negative 4, which is positive 32, and then plus negative 13. You can add, because of the commutative property, in any order you want. So what I would do is go negative 16 and negative 13, which is going to be negative 29. You can actually show that step if you wanted to. Y equals negative 29 plus 32. When it's a negative and a positive being added together, it acts like subtraction. So 32 minus 29 is going to be 3. We have more positives than negatives, so y equals 3. So your vertex is negative 4, 3. We know it's going to open down, so I'm going to label it above it, negative 4, 3. Now, step number 3 is going to be to find 2 other points. Now, again, we want to use points that are simple. we may be able to use 0 and 1. We're just going to have to see. If I were to use 0, then I would come in and all of it would be negative 13. And even though I love to use 0, 0, negative 13 would put me off the graph, and that means I can't use 1 either. So in this case, we aren't going to be able to use that nice, easy 0, but that's okay. We can use other points. So we've got our x and our y and our work. It's not really that difficult to use negative 2 and negative 1. So this is negative 4. I could have used negative 3. I'm going to go ahead and use negative 2, just a little bit simpler, but you could use negative 3. So negative 2, and then I'll go ahead and use negative 1. So we're going to the right of the axis of symmetry. Both points need to be chosen to the right. So it will be y equals, and we go into this equation up here, negative 1 times negative 2 squared. Notice I changed that negative to a negative 1. I'm going to use the additive inverse again. Subtraction changes to addition, plus negative 8 times negative 2, and then plus a negative 13. This is where knowing the additive inverse really helps you to not make math errors. Okay, so we have y equals negative 2 squared is 4. Negative 2 times negative 2 is 4, times negative 1 is negative 4. Negative 8 times negative 2 is positive, so it's going to be plus 16, and then plus a negative 13. Again, I would go ahead and combine the negative 4 and the negative 13, which is negative 17. So y equals negative 17 plus 16. And negative 17 plus 16 is negative 1. So I have the ordered pair negative 2, negative 1. So we're just going to highlight what I've got here, just to keep everything nice and organized. Here's my axis of symmetry, and you can see that right here. Here's my vertex, negative 4, 3, and you can see that right here. So now my first ordered pair is negative 2, negative 1, and I'm going to go ahead and write that, plot that, negative 2, negative 1. Write my ordered pair, negative 2, negative 1. Now, step 4, we're going to go ahead and do that over here because we don't have enough space. Step 4 is going to be to reflect step 3 points. Reflect the step 3 points to get 2 more points. You need a total of 5 points. So that'll give us our 5 points. So I'm going to do step 3 and 4 simultaneously. That means at the same time. So negative 2, negative 1 is 2 from the axis of symmetry. We go 2 the other way. That's going to get us negative 4, negative 1. So the ordered pair is going to be negative 4, negative 1. Oh, wait. Excuse me. I can't read. That's negative 6, negative 1. There's negative 4. Excuse me, negative 6, negative 1. So you can see there's negative 4, negative 6, negative 1. Let's label that negative 6, negative 1. Okay, so here's where we are. We've got this point, negative 6, negative 1. We've got negative 2, negative 1, so we're up to 3 points. Now going back to step 3, we are going to use negative 1, and that's going to be y equals negative 1, just substituting it in, times negative 1 squared. I'm going to change subtraction to addition, and then 8 goes to negative 8 times negative 1. This is just to make sure I don't make signing errors. Then it's going to be plus a negative 13. I'm using the additive inverse. So y equals negative 1 squared is 1 times negative 1 is negative 1, plus negative 8 times negative 1 is 8, and then plus a negative 13. So we have a negative 13 and a negative 1, which is a negative 14, plus 8 is going to be a negative 6. So negative 1, negative 6 is the ordered pair. Now, I'm running short on time, so no, the 2 other flaps are going to be on another video, and you're going to have to just look at the rest of this. Here are the calculations for the 4th point, negative 1, negative 6. And then when you look at the reflection, it's negative 7, negative 6. The last 2 flaps, flaps 3 and 4, are going to be on another recording because I cannot fit it on this one.